Alrighty, 8th graders, we're going to review Module 8, which is solving systems of linear equations, either by graphing, substituting, eliminating, and multiplying, or any kind of special systems. So let's start with number 1. So this one is by graphing, so I'm going to get it to the form of y equals mx plus b. So for me to graph it with my initial point and then my slope. So the first one, let me work with that one. So I have x plus 2y equals 1. So I have to move the x to the other side because I want to get y on just one side. So then I have 2y equals negative x plus 1. Now, there should not be a coefficient of 2 in front of the y, so I'm going to divide by 2 to get rid of that. And what I do to one side, I do to the other side. So then I end up with y equals, and then I'm going to take those two separately like that. So that one is negative x over 2, which is basically negative 1/2 x, okay, because there's a 1 in front of the x. And then I'm going to take that separately, so that will be b plus 1/2, okay? So that's the first one that I have. So I have y equals negative 1/2 x plus 1/2. So I'm done with the first one. So now I'm going to deal with this one. Then I have negative x plus y equals 2. I need to move the x to the other side. So I add to the inverse operation and get rid of that. So then I have y equals x plus 2. Remember, we want to start with the x, and that's a positive, so I say it's going to be plus 2. So that will be my second equation in the slope-intercept form. Okay, so I'm going to graph. So I'm going to start 1/2 on my y-axis, so it's going to be right here. I'm going down 1 and 2 over to the right. So I'm going to go down 1, 2 over, 1 down, 2 over, and I can do the same thing over here. So I'm going to go 1 up and then 2 to the left to make a negative 1 up, 2 to the left, and then I can connect. And then I'm going to grab my second equation here. I'm going to start at 2 on my y-axis, and it has a slope of 1. So that will be that. 1 up, 1 over, 1 up, 1 over, 1 down, 1 over, 1 down, 1 over. So I already see the point right there of connection. So then this is the point of intersection. That is my solution. So that will be negative 1, comma 1. Okay, that's the point of intersection. Now I'm going to check to see if my answer is correct. So then my x is negative 1, then plus 2 times 1 equals 1. Let's see if that's true. So I have negative 1 plus 2 equals 1. That was going to give me 1 equals 1. Yes, check. Let's check the second one. So now I have negative x, which is negative 1, plus 1, which is my y, equals 2. So we have, remember, the minus and negative is basically a positive. So I have 1 plus 1 equals 2. Is it true that 2 equals to 2? The answer is yes. So therefore, my answer is correct. Okay. So let me give you one to do for this one. So go ahead and do that one for me. That one's actually kind of done for you. You just have to graph it. You don't have to solve in the form of y equals mx plus b to graph it. So go ahead and do that for me. So let's get to lesson 2, which is solving by substitution. So in this one, again, I have to substitute. So I want my temptation right now is to solve by elimination because that's easier for me, but I have to do substitution. So to substitute, remember, we need to get x equals to something or y equals to something. Okay, so let me go ahead and do that. I am going to pick this one because I see that there's only one x, so it's going to be easier for me to work with. If I pick this one, I'm going to have to either divide by 3 if I want to solve for x, or I'm going to have to divide by 2 or negative 2, depending on how I move the numbers to solve for y. So I think this one is my best choice. So then I have x plus 2y equals 9. So I want to get x on itself, so I don't want to isolate it. That means I'm going to move this term to the other side of the equation. And to do that, I have to do inverse operation or opposite operation. So what's the opposite of it? Plus 2y minus 2y. So what I do to one side, I must do to the other side. That cancels out, and then with x equals 9 minus 2y, or you can also write it as negative 2y plus 9. Okay, so let me go ahead and write that down so I don't forget it, because I'm going to need this piece. So then, now, because I use this one to find my x, I have to plug that in right here. You cannot use it for the same one. Okay, so then I'm going to plug it in there. So every time I see the x, I'm going to plug this whole thing in. So I'm going to have 3 times that, 9 minus 2y, close parentheses, minus 2y equals 11. So now I have to distribute my 3 on both of them. So that's 27 minus 6y minus 2y equals 11. I'm going to combine like term, which is this right here. So I have 27 minus 8y equals 11. Move my 27 to the other side of the equation. So that will be my subtracting. So I end up with negative 8y equals negative 16. So divide by negative 8, divide by negative 8. Negative divided by negative is a positive, and 16 divided by 8 is 2. So my y is 2. Okay, so that was the hardest part. Now, once I solve for one of the variables, then I can plug it into whichever one I want. Okay, so I don't like dealing with negatives, so I'm going to pick this one again. So x plus 2 times 2 equals to 9. So that will be x plus 4 equals to 9. Subtract 4, cancels that, x equals to 5. So then my point of intersection is going to be 5, 2. Let's see if that's true. So whenever I see the x and the y, I'm going to plug those values in. So I have 3 times x, which is 5, minus 2 times 2 equals 11. Let's say that's true. That's 15 minus 4 equals 11. Is it true that 11 equals to 11? Yes, correct. It's right. Second one over here. So I have 5 plus 2 times 2 equals 9. Is it true that 5 plus 4 equals 9? Yes. So therefore, my answer is correct. Okay. So the answer for that one is 5, 2. That's where the lines are going to intersect. So therefore, that is solution for both of them. So let me give you one to do now. Okay. So you have that system of linear equations. It's easier because you already have the y there. So you have to plug it in here. Solve for x and then solve for y afterwards. Okay. Here you go. Let's do solving by elimination. So this one, I can either subtract or add. In this case, I'm going to look to see if there are any opposites. And no, there are not any opposites. And so I cannot add. So I'm going to subtract. So I'm going to subtract the bottom one. Okay. So essentially what I'm doing is I'm saying 3x minus 2x, y minus y, and 9 minus 5. So you can either do that or you can distribute a negative to each one of those terms. So yeah, way you don't forget. And you can say negative 2x minus y equals negative 5. Okay. So you can do it that way. That way you don't forget that you're subtracting. So let me go ahead and do it that way, but you don't have to. So 3x minus 2x is just x. That cancels that, equals 4. So then I have x equals to 4. And then I can plug it into any of those. So let's try to do the first one. So 3 times 4 plus y equals 9. So that would be 12 plus y equals 9 minus 12 minus 12. And then that gives me y equals negative 3. So my point of intersection will be 4, negative 3. Okay, let's see if that's true. Let's check. Times 4 plus negative 3 equals 9. Is that true? So we have 12 minus 3 equals 9. Is 9 equals to 9? Yes, correct. That's right. So let's do the second one. 2 times 4 plus negative 3 equals 5. That will be 8 minus 3. Is it 5 equals to 5? Yep. So that one's checked. I'm good with it. So let's go and give you one to do. Okay, so solve by elimination. Remember, if they see any opposites right away, you can add them. If not, then you're gonna subtract them. Okay. And remember, if you subtract, just make sure that you keep you know that you're subtracting that from that, and this from that, and that from that. Okay. Let's get to the elimination with multiplication. So in this case, I don't see any opposites. I don't see any that are the same. So therefore, I'm going to have to look for the LCM between two numbers. If I look at the x's, my LCM will be 6. So I don't want to deal with that because I would have to multiply this whole thing by 3 and this whole equation by 2 to get it to 6. But if I look at the y's, my LCM will be 8. So I already have an 8 there. So then I want to get an 8 over here. So then what I have to do is I'm going to multiply by 4 to get to a negative 8. And I multiply that to each of the terms inside the equation. Okay. So now I end up with 12x minus 8y equals 20. And I'm going to bring this one down over here. So then I can do addition, right? I can't add them because this is going to cancel out. So 12x plus 2x, that will be 14x. And then over here I have 42. Then I divide by 14, and that will give me 3. So x equals to 3. And then I'm going to plug that in any of the two equations right here. So let's go ahead and do the first one. I don't want to deal with the negatives over here. Well, that's the second one, I guess. So I have 3 times 3 minus 2y equals 5. So I have 9 minus 2y equals 5. I'm going to subtract the 9 on both sides. It cancels out. I end up with negative 2y equals negative 4 divided by negative 2 divided by negative 2. Negative divided by negative is a positive, so that's y equals to 2. So then my point of intersection will be 3, 2. And let's check to see if that's true. I have 2 times 3 plus 8 times 2 is that 22. I have 6 plus 16 is 16 plus 6, 22. Yep, so that one's right. And then over here, I have 3 times 3 minus 2 times 2 equals 5. So I have 9 minus 4 is that 5 equals to 5. Yep, so that one's right. Okay, so it's that point intersection. Let me give you one to do. Okay, so solve by elimination and multiplication. Remember, you're going to find your LCM between either the y's or the x's and then multiply by that. In this case, because you see that all of them are positives, you're going to have to eliminate by subtraction after you get it to your LCM. Okay, let's do 8.5. So this one is solving system of special systems of equations. So let's go ahead and try to solve for that. And this one you can use any method. So what I'm going to use, because I don't see anything that I can eliminate yet, I'm going to have to use this method right here. You can also use substitution if you decide to do that. I'd rather do this. So let me multiply by 2 to get that to negative 8. So then I end up with 2x minus 8y equals negative 6. And then I can bring this up here. Down here, not up here. So then that cancels out. That cancels out. That means that is 0 equals negative 1. Is that true? The answer is no, that's not true. So therefore, this one has no solution. Okay, that means that they're going to be parallel lines. Okay, let me give you one to do for this one. Okay, so that's the one you're doing, and just going back to the different types of solutions. Remember, when there are intersecting lines, you're going to have one point of intersection. So then this one has one solution because they're going to be intersecting at this just one point, okay? When you have parallel lines, meaning they have the same slope, right? They will never touch, therefore you have no solution, okay? So if you see two lines that have the same slope, right away you should know that that has no solution because they will never touch, therefore they don't have a point in common. And then this one is basically the line over the same line. So this one is the same line. So this one has infinite number of solutions. So many solutions, right? Because it is the same line. And what you're going to find with this is basically if you get it to the at least come multiple and then you start working it out, you'll be able to see that it's basically the same equation. Okay? Alrighty, guys. We're getting through this. You got this. You're smart. Don't give up. Don't give up. And don't let... Don't feel defeated by math, okay? Math are just patterns that human beings found of God's beautiful creation. Alrighty, well, thank you very much. God bless you. Remember, you're amazingly brilliant, and math is magical, I guess, because we can find the patterns of God's beautiful creation. God bless you. Bye-bye.